Good afternoon, everyone. So I'm Kian Wee Chen. I'm a researcher with Global Environmental Technologies Inc., the US subsidiary of Senken. So I'm here on behalf of my collaborators from all the other institutes. So it's a multi-institute research project here. So just to give an overview of the project, we are evaluating the energy performance and the thermal comfort of air system or air system versus radiant cooling systems. So the method has been we are simulating the energy performance based on physically simulating the loads of the space. And for the thermal comfort studies, we are actually doing thermal comfort surveys of 78 participants. So before going into the project itself, I think it's worth talking about the living lab that this research project has taken place in. It's the Zero Energy Plus building by the Building Construction Authority of Singapore. It's probably it's one of the first positive energy building in Southeast Asia, and probably the only one maybe until someone come out and say they're actually the first one. But it's one of the first positive energy building in Southeast Asia. So it's an academy building, so for retraining built environment profession. So it's kind of like a living lab for zero energy building technologies. They partner with CBE and Simberbest, which is the Singapore arm of Berkeley, to turn the building from zero energy building to positive energy building. So it's currently a positive energy building, and they partner with Senken also. So one of the floors, on the second floor, on top of CBE's floor, we are testing our radiant panel cooling system right there, and that's where we did this project in. So the setup in the space, so it's a living lab, so it's currently being used by the authority. It's an office space, it's a hot desking space, and because it was built for research purposes, we have actually multiple modes of cooling there. And since it's in Singapore, it's a tropical climate, so there's only cooling. So the two modes that was used in this experiment setup was the radiant system mode, where we have a DOA system, which is providing dedicated outdoor air system into the space, and we have 4 zones of radiant panels. So for the all air system, we are using fan coil units, and also with 4 zones, and also for the ventilation side, we are still using dedicated outdoor air system. So it's quite a 1:1 comparison between the air system and the radiant system. So you see, for working on the energy evaluation, we place multiple physical loads of bulbs, heat panels, and radiators, and humidifiers to simulate occupancy load. I won't go into detail, but essentially we are simulating partial occupancy, medium occupancy, and maximum occupancy of the space. You can see from the results for the air system, we did 23 degrees Celsius, 73.4 degree Fahrenheit set point. So because that's the baseline in Singapore. So in Singapore, usually people set it at around that set point for office cooling. And we also did 26 degrees Celsius, which is at 78.8 degree Fahrenheit for air system. So you can see immediately the energy consumption dropped by 22% once you increase the set point temperature, even for air system. For the radiant system, because 26 degrees Celsius or 78 Fahrenheit is the recommended set point that the authorities are pushing for energy saving, and at the same time allowing for enabling comfort. So they feel 78.8 is where Singapore should be at set point. So for the radiant panels, we only simulate loads for that set point, and you can see it only reduced by another 4% of energy reduction. And this reduction is mainly from the reduction in blowing air into the space. So we no longer have any fans for the sensible cooling side. And that 4% reduction is essentially from not using fans for delivering air into the space. And we are assuming a COP of 6 for the chillers because it's only one office space, about 2,000 square feet. we don't have our dedicated chiller for that space. So we are taking chilled waters from the central system. So it's roughly about COP of 6. But the thing is, if we were able, because since here we are separating both the sensible cooling and the latent cooling here. So if the sensible cooling was using a much higher COP chiller, because you don't need that cold of a water for providing sensible cooling, you can immediately drop another 15% of energy consumption here. So the takeaway here is separation of loads of latent and sensible is important. And if you're able to have 2 independent chillers to do that, that will have much more energy savings. So the experimental setup for the thermal comfort is we have 78 participants separated into 5 groups. And it's a 4-hour thermal comfort studies, and they are exposed to both the air system and the radiant systems in a 4-hour with a 1-hour break in between. And they are jumbled up to make sure that there are no biases and the experiments is reliable. So the thermal satisfaction and the preference result here, there's some minor differences with the radiant systems performing showing a little bit less, but they're not statistically different essentially. So they are essentially giving very similar results. And also for thermal sensation distribution, you can see that it's much closer. And for both of the results, the occupants actually prefer, 1/3 of the occupants actually prefer more air movement. So this is actually a potential for occupants in the tropical climates that actually like more air movement. So with more air movement, you can actually probably increase the set point higher and save more energy. So in conclusion, so radiant systems reduces energy consumption because of the because we are not delivering sensible heat through air as a medium, and with a low lift chiller we can further reduce the energy by up to 15%. And for and radiant and air systems provide equivalent comfort to the occupants. So, and for occupants in the tropics, they desire more air movement, and so designing with that would definitely reduce the energy consumption and at the same time maintain the thermal comfort. As I mentioned, the video is not playing. The lab is a living lab, so you can scan the QR code and you can actually see a 3D dashboard of the existing thermal condition. So I think now it's probably the systems are probably not on, but you can look at it anytime. So you'll be able to see all the data for the past 24 hours. So for any collaborators, we are quite open to working on research project with the space where you can pull the trending data and so on from us. So come talk to us if you're interested. And Senken has invested a lot on doing radiant panel research. So in the US, we're working with CBE. So if you have visited the environmental chamber in CBE, that's the Senken panel that was used in this project too. And back over at Princeton, we are working with Ellinger Center from Princeton to look at renewables powered radiant systems. So essentially geothermal powered radiant cooling and radiant heating. And back in Japan, we actually have a zero energy building, which also have a live dashboard. So if you can scan the QR code, you'll be able to see the data. But the dashboard only function between 9 to 5 p.m. in Japan time, so it's probably not running now. So you might have to look at it at your own spare time at night. Thanks for your attention. So you can scan this QR code to get a copy of the paper that this project is based on. And please join the design guide for radiant system later at the breakout section. Thank you.